This is an introduction for homework for Chapter 4. And except for introducing the similar problems you may meet in your homework, and like to give a brief introduction of the models, the network planning models in project management. They are two best known network planning models, and one of them is what we focus on today, called the critical path method, the CPM model. And what is the network planning model? This is like we analyze the activities in a project, and we according the breakdown information to draw a network which connect all the activities together considering the sequence. And because we have the sequence, so we have the path across the all of the activities in the project. And what we also need to know is the critical path. The critical path is the non-least path which occurs to the activity. And the CPM is like the critical path. We mentioned the critical path to provide a wide range of scheduling information about how to schedule the activities in the project. So this is what we need to know about the basic concepts before we learn the homework, before we learn how to draw the network, how to find the critical path, and how to calculate the time and estimate the time. So about the critical path method, the first step, like for any like the model you like to use, by the CPM models, you need to identify every activity, and then you need to identify each activity to be done and to estimate how long it will take. So for different activities, you need to know what is the duration for that activity could be completed. And the second, you need to determine the required sequence. For a whole project, like if we want to construct a hospital, before you buy the land, you are not able to construct it, and before you construct it, you are not able to move the machines, the equipment into the plant. So this is the things you need to determine the sequence of the required sequence for activities, and then you will be able to draw the network diagram. After that, find the critical path according to the time you have estimated for all the activities. Find the non-least path, the path which takes the non-least time. The last one we need find for time here, which is the ES, EF, LS, and LF. This is after you know these four numbers here, the time here for each activity, you will be able to schedule, and you will be able to know all the information you need to know when you want to schedule the project. So let's take a look at the homework. This is an example for the textbook. So the table here provides the information for the activity name and what is the designation, which is means like for the design, this is the design activity, and also provides the information of immediate predecessors. This is what the former activities compare the destination, and also the estimate time. So if we're back here, we need to estimate how long the activity takes. So for design, it may take 21 weeks, and for build a prototype, it takes 5 weeks, and so on. So according to the information, except for the estimate time for each activity, we also know the sequence information because we know the immediate predecessors here. So we know all the information we need to know before we draw the network diagram. So how to draw the network diagram? The first, we need to mark the name for the activity. And if you want, you can write down the estimate times for the activity. And then you can use a circle, or sometimes some people also use a triangle to circle all the activities. So we have two ways. And in the textbook, we use a circle around. And the next step is we need to analyze all the activities. So this is what we have for A. And if we take a look with the immediate predecessors for A, for the design activity, we have a short line here, which means no immediate predecessors for A. So we just like the A is the beginning. And then we move to the next one, the B. So for B, it takes 5 weeks, and the immediate predecessors is A, so we use the arrow to stand for the sequence. A is the formal activity for B, and we move to the next. For C here, it takes 7 weeks, and we still use a circle and use an arrow because for C the formal activity is still the design, so we have the design over there, and so on and so on. And after that, after you go across all of the activities, you will be able to have the figures over there. So for D takes 2, and D is the formal activity for D is B, so the B here is the arrows. But be noticed the activity E and F and G, because for these 3 activities, the right equipment, right methods, right the final report here, each of them have 2 formal activities. So for example, for E here, it takes 5, and we need 2 arrows to stand for the sequence, which means before you complete C and D, you will not be able to start the activity E. So before you evaluate, before you complete evaluating equipment and testing prototype, you will not be able to write the equipment report. And the same as the activity F. So the F also has 2 formal activities need to be done before it starts. And the G is followed by E and F. So after you writing these 2 reports, you will be able to write the final report. So this is how we draw the network diagram. And the next step, you may need to determine the critical path. So how to determine the critical path? If we're back here, so for the critical path, this is the knownest time. So first we need to know what is the path. For the structure here, we have different paths for the beginning to the end. And for example, we have the path for the A to C to F to G. But when we for the A to C, actually the C could be to the C could to the F or to the E. So we have another path over there. And if you go to the E, then we have E to G. So this is another one. And we also have path for A to B. If we are not going to C, we go to B, and for B to D. And for D, we have 2 paths over there. So actually we have all the 4 paths here. So what is the critical path, which is the knownest path? We need to sum all the activity time together. For A to C to F to G is 21 plus 7 plus 8 plus 2, which equals 38. And the same, we can calculate another path for A to C to E to G. So we have 21 plus 7 plus 5 plus 2, which is 35. So this is how we can calculate all the paths over there, and we are able to find the path which takes the longest time, and that path will be the critical path. Okay, so this is how we determine the critical path, how we draw the network diagram. And the next step for the CPM you may meet another problem is about like determining these four numbers. Before we know how to determine these four numbers, we need to know the things. What is the ES? What is EF? What is LS? And what is LF? The ES and the EF, which means the early start time and early finish time, they are the activity can start and finish with the earliest start time and finish time. So again, the ES and EF, which is early start time and early finish time, are the earliest time that the activity can start and be finished. And similar, the LF, which means the late start time and late finish time, are the latest time that the activities can start and finish without any delaying. So when we want to calculate these four numbers, that we can make detailed schedules for each activity. The thing is, like, we need to start for the ES because this is the earliest start time, earliest finish time. So we start for the ES, and when we calculate the E, these two, we for the start to the finish. So if we back to the structure here, when we want to find the ES and EF, this is the direction. We start for the activity A until activity G. But when we calculate the latest, we for the finish to the start. So when we find the latest start time, latest finish time, we start with activity G for this specific example to activity A. So this is how we analyze the stuff. And now we're back to here. We need to know what is the earliest start time. Actually, this is the earliest finish time of immediate preceding activity. So this is the earliest finish time, EF, of a former activity. And the EF equals the ES plus T. The LF, this is the finish time, so this is the latest start time for the activity, and the LS will be LF minus T. The T is the estimate time for an activity. And let's take a look at the example here. So the first we need to start for the ES and EF. By the way, for an activity here, we use a circle. So the ES will be the above left side, and this is the EF, and this is the LS and LF. So for the left side, it will be the start time, and for the right side it will be the finish time. But the above side will be the earliest time, and the early time, and the below side are the late time. So this is what I want to mention. So here, if we're back here, for activity A, we start for the ES. Actually, we for the ES, so we for the A to G. And for A, the earliest start time is the earliest finish time of a former activity, but A is the beginning, so the earliest start time for A will be 0. And the earliest finish time equals ES plus T. So equals 0 plus T. T is the estimated time for activity A. So it would be 0 plus 21. It will be 21 as the earliest finish time. And then we can move to C and B, because for C and B, the earliest start time will be the earliest finish time for a former activity. C and D, they only have one former activity, which is A, respectively. So the earliest finish time for A, the EF for A will be the ES for C and B. So 21 here, 21 here, and the early finish time will be 21 plus 7, 28, and 21 plus 5, 26 as the EF for B. And then we move to F. Take a look with the F here. Actually, you can move to D or F, it depends on. But if we take a look with the F has more than one former activity. So F has C and D, also the predecessors. And if we have two EF here, but for this example, the two EF, the EF for C and D are the same, so we can just write the 28 directly as the ES for F. But what if the EF here is 30 and the EF is 28 for C? Just make a suggestions. If we have that one, and for F we have two different EF. So what is the number for the ES for F? We need to choose a larger number. So if we have 28 or 30, then we may need to choose the 30 as the EF for F. But because for this problem, both C and D, the EF are 28, so we just directly write 28 here, and 28 plus 8 will be 36, and we move to G. So for G, like we have, this is what I have mentioned. We have the 36 as the EF for F, and we have 33 as the EF for E. So for G, it has two choices. The 36 and 33. So which one should we choose? We need to choose 36. We can consider a real situation because the G can start after all of the E and F have been completed. So if we need 36 to go across all the activity until F, and we need 33 across A to E, the 33 weeks. So if you want to start G, actually, you need to wait until F has been completed, then you can start G. So it should be the largest number, the largest EF, which is 36. So the total, the EF for G will be 36 plus 2, 38. This is how we compute the ES and EF. If we like to compute LF and LS, we need to start for that direction for the last activity to the first activity. So for the G, we know like actually for the whole project, the critical path is like the longest time we need will be 38 weeks. So the L for back here, the LF will be the latest start time of the activity that immediately follows. For G, this is the last activity, so the LF will be 38 because we know the longest time for this project is 38. And we have 38 here, and this is LF, so the LS will equal LF minus T. So LS for G will be 38 minus 2, which is 36. And the 36, the LS for G will be the LF for F and E. So both F and E we have 36. And 36 minus 8 will be 28 as the LS for F. 36 minus 5 will be 31 for the LS for E. And way back here. So what if for D it has two activities which D is followed, F and E. So we have two numbers here, the 28 as the LS for F and 31 as the LS for E. When we calculate the early time, we always find the largest one. But when we calculate the late time, we always need the smallest one. So if you have more than one choices for D, if you have 28 and 31, then choose 28, the smaller one, and use 28 minus 2, have 26. And for B, the B is only followed by D, so we have 26 over there, and we have 26 minus 5, 21, and this is the whether this is a 21 or not, it need to compare with C. So this is how we calculate these four numbers. And after you have these four numbers, you will be able to make a detailed schedules for it. And the next things I want to introduce is about a time cost model and the project crashing. So sometimes if we consider the time, the detail time and the cost, we know that if you want to reduce the time, which means like you may need to increase the money. For example, if the activity should be done in 5 days and because of the requirements, you need to complete it in 3 days, then you may need to hire more employees and put more inputs that you can reduce the time. But at the same time, because of you hire more employees and you spend more on inputs, the cost will increase. So this is what we call the project crashing, the time cost models. This extends the CPM model to consider the trade-off between the time and the cost. So because the project crashing actually extends the CPM, so the first step we need to prepare a CPM type network. And the step 2 is determine the cost per unit of time to expedite each activity. What's that mean? So take a look with the figures over there. And this time we have 4 numbers here. The CC stands for the crashing cost. The CT stands for the crashing time. Crashing time. And the NC stands for normal cost. And the NT stands for normal time. So this is what we use these 4 numbers here. So for activity A, how to determine the cost per unit of the time? What's that mean? For activity A, actually we have a normal time. If we want to complete the activity A, we need 2 days, maybe 2 days, maybe 2 weeks. This is the normal time. And the normal cost for activity A will be 6. So this is how we complete activity A. But what if we want to like shorten the time for the activity A? If it's short for the 2 to 1, the cost will be 10 according to the figures here. So this is the point stands for the crashing cost and crashing time. So the crashing time will be 1 and the crashing cost will be 10. So this is how we have all the information here, and we connect these 2 points together. What's that mean? If we want to know the cost per unit of the time, we just need to know the snowing. I mean the slope of this linear line. So if we use the CC minus NC divided by the NT minus CT. So for activity A, we have CC will be the crashing cost is $10 minus $6 divided by 2 minus 1 is 4. What's that mean? It means if you want to reduce 1 day, it may increase $4. If you want to reduce 2 days, if possible, then it will be 2 times 4. It will be 8 because 4 here is the cost per unit of the time. So this is the determine cost per unit of the time. So this is the step 2. The step 3 is to compute the critical path. So for the network we have over there, we need to we need to find the critical path. So for this example here, we have path for A to B to D, or we have another path for A to C to D. For A to B to D, it will be 2 plus 5 plus 3, it will be 10. And for A to C to D, it will be 2 plus 4 plus 3, it will be 9. So A to B to D will be the critical path because 10 is more than 9. And this is the step 3. We find the critical path. The step 4 for this method is we need to shorten the critical path at the point where the costs are the lowest. What's that mean? It means now we know if we want to complete the project, we need to spend 10 days because the critical path is 10. And what if we want to shorten it? What if we want to reduce the time like for 10 to 9? We want to reduce 1 day for the whole project. How we shorten the critical path? Because the critical path is the longest path. This is what we can shorten the whole path over there. How do we shorten there? Because we have for the critical path we have activity A, activity B, activity D. So which activity we should reduce the time? We need to find the longest the known list cost per unit of the time. So take a look with the tables. For A, the cost per day to expedite is $4, and we can use the same way to find the determined cost per unit of the time. And we'll also be able to know what is the max numbers of the days that can be shortened. For activity A here, the question time is 1, the normal time is 2, so we know we only have 1 day to shorten A, and this is all of the information we can have. The 3 comes for 5 minus 2, 1 comes for 4 minus 3, and the A comes for the 3 minus 1. So for this example, if we want to reduce 1 day, then the critical path nowadays is A to B to D. So for A, the cost per unit of the time is $4. For B, the cost per unit of the time is 3. And for D, it will be 2. So we need to choose the lowest cost for the activity in the critical path. So we choose to reduce D. So the next step here is we need to reduce the D. The normal time for the D is 3. Now we reduce 3 to 2 because we minus 1 day. So we have D as 2. And this is what we have. And this is what we lower list. And then the total time will be 9. But what's the total cost? So way back to the first line here, this is the normal time and the normal cost. We know the normal completion time for the project is 10, but how we obtain the 26? We need to back to the information on the textbook. So we know that for this project, the direct cost is 26. This is what we already know. Because if we want to complete the whole project, we need to complete all the 4 activities here. So the direct cost for the 4 activity over there will be, for A, the normal cost is 6. And for B, the normal cost is 9. For C, the normal cost is 6 also. And for D, the normal cost is 5. So we use 6 plus 9 plus 6 plus 5, we will have 26. This is if we want to complete the project here, the direct cost is 26. And we also know if the project takes longer than 8 days, the indirect cost increase at the rate of 5 per day. The information you can find for the page 89 on textbook. So if we for the project here, because of the project completion time, the normal completion time for this project is 10 days, which is more than 8 days. So the total actually will be 26 plus 5, because we have 2 extra days times 2, and we have another $10. If you check the textbook, we have the $10 for the total indirect cost. So the total cost for this problem will be, for this project will be 46. And here the table only needs the total direct cost. So if we keep the normal time to complete the project, the direct cost will be 26, which is 6 plus 9 plus 6 plus 5. This is the 26. and the time for completing this project is 10 days. And now if we want to reduce 1 day, so we consider to reduce D, because D has the lowest cost for per unit of the time, the cost per day to expedite. So we reduce the D for 3 days to 2 days. So this is what we have. We use 1 day to company A, use 3 days, they are also keep the same, but we reduce 3 to 2 for as the time for activity D. So the project completion time will be 10 minus 1. The total time for completing the whole project will be 9, but the total cost, the total direct cost will be 28. And think about what is the total cost if we reduce 1 day. This is the total direct cost and the time for 10 to 9. So if we just stop here, the second line here, we stop, like we reduce only 1 day, then the total cost will be the total direct cost plus total indirect cost. So we have 26 plus 10. This is always the total cost as the indirect cost, and we have a penalty as 5 for per day when the total day except for 8 above 8, and now we only need 9, the 9 days, so we only have 5 here. Sorry, this should be 28. So the total cost here will be 43. So this is if we want to reduce 1 day. Actually, the total cost will be 43, and the total time will be 9 days. If we wanted to reduce 2 days, then we continue to consider the thing. So we still need to shorten the critical path. So after the second line, if we move to the third line, the critical path still the ABD, and again, if we still consider A, B, and D, the lowest cost is still D. So we can reduce D for 2, because for the second line, the D have been reduced 1 day. So now we only have 2 days for D, and if we continue to reduce the total time for the whole project, we reduce D, the activity D, for 2 to 1, so the D only need 1 days, and the total time will be reduced to 8 days. And the same with the line 2, like we have 28 plus another $2 for as the direct cost, so we have 30 for the total direct cost for the line 3. As the line 4 here are similar to line 3, but even though we still have the ABD as the critical path, so when you want to calculate the critical path, we need to like some students may feel confused why still the ABD as the critical path, because the time for D has been changed. So here is 1 day. If we have already reduced 2 days, as if we already reduced 2 days for the whole project until the third line here, so the critical path is still ABD, because now we have ABD, it changes to 5, and D is only 1 day, so we have 8, and 8 is smaller than the ACD because ACD hasn't been changed. So we still have the ABD as the critical path. But the thing is, A and B, if we consider 9, 4. A, B are the only two activities which are on the critical path and can be reduced, because D, for the 9, 4 here, D is 1 day, and 1 day is the crashing day for D. So the D cannot be reduced anymore. So the things we can reduce is only for A and B. But here is the thing. If we back to the structure, the network structure here, B and C are parallel. So if we want to reduce B, we need to reduce C at the same time, or it will make no changes. So for the stuff here, if we consider the 9, 4 here, for 9, 4 here, if we only consider critical path, the C doesn't in the critical path. So for A and B, if we compare 4 and 3, we need to choose to reduce B. So B reduced for 5 days to 4. So the total time will be 7 days, and we have 30 plus 3, because if you want to reduce 1 day for B, the total direct cost will increase $3 for B, so it will be 30 plus 3, 33. And if we move to the 9, 5 here, all of A, B, C, D are on the critical path, because ABD and ACD, the path has the same time. So ABCD are on critical path. So this is what I have mentioned. Because B and C are parallel here. So if all both of them are on critical path, if you only reduce one of them, it makes no change. So you need to, if you want to reduce B, at the same time you need to reduce C. So we consider what is the lower least cost to the expedite. If you want to reduce 1 day for A, then the total cost will be 4. But if you want to reduce B, which means you also need to reduce C, so it will be 3 plus 2, which is 5. So for the 9, 5 here, we need to choose to reduce A, and A will only have 1 day to be shortened. So it will be 6 days, while we have 33 plus 4, 37 as the total direct cost. And the same if we move to the 9, 6, and because we are not able to reduce A, because the question time for A is only 1 day, so we have already reduced for the 9, 5. So we are not able to reduce A, so the only choice for us, if we want to still reduce the total time for this project, we need to reduce both B and C. So it will be 37 plus 5, which is 42, because we need to reduce B for 1 day and reduce C for another day. So it's 3 plus 2, 5, 37 plus 5 will be 42. And for the last one, and actually this is the last one because we are not able to make any reduction for the time, because we have already, the D has been the question time and A become the question time, and after 7 the C cannot be reduced anytime. So the only activity we still can reduce the time is B. So for B here, because all of them are on the critical path and we can only change B and we are not able to change C, so actually the total completion time will not be changed. It still be 5 days because we are not able to change C. But the total cost, because you want to reduce B, so the total cost will be 42 plus 3 because B has 3, so it's 45. So this is how we calculate the cost and the time if we want to reduce days. And you can reduce one by one if you want to. if you have the information for all of the activity, and then you can move to the last step here, which means you are not able to reduce any time. So this is the final stuff you can reduce. And if you check your textbook on page 92, you will be able to see figures 4.12, which including the total direct cost, the total cost, and total indirect cost. Because even though like we have for the total indirect costs, we have $10, and we have another $5 for per day if the total days except for 8 days. But if, for example, for the last few nights over there, the 7 is not excess to 8, the 6 is less than 8, so we do not have that part of the penalty cost over there. So the total cost, which means the total direct cost and total indirect cost may change. So this is, and according to the figures on the textbook, you may see that the minimum total cost will be 8 days. So the 8 days will be the best choice. Like you reduce the D for the 3 days to 1 days, and then you will be able to reduce the total cost and the total time. So this is about the project question problem, how to solve it. And if you want to practice by yourself before you do the homework, the solve problem 4 on page 98 will be helpful for you.